Hi everyone, welcome back. Looking at ratios with fractions, if I want to muck students up and make a test question, it's harder to put fractions into it. So when we're looking at ratios, we don't usually want them written as fractions. Mind you can get recipes, have all sorts of decimals and fractions and all sorts of things happen. But if I've got 1/4 compared to 3/4, now some of you looking at this video will go, too easy, too easy, too easy, too easy. Maybe you jump ahead and just go straight to a couple of these and make sure you're okay. Don't watch the video all the way through. If I've got 1/4 to 3/4, a lot of people will look at it and just say that's 1 to 3. Now here's the basic reasoning. 3/4 is 3 times bigger than 1/4. So that's 3 times bigger than that. So you can just write it as 3 to 1, or actually it's 1 to 3. But I want to show you the method first of all. If I've got a denominator saying 4 and a denominator saying 4, if I times this side by 4 and I times that one by 4, what's going to happen to it? So I can write it there if I want to. That's the way I want to think about it. I could just write it here, like that and like that. Now please, I made that look like a numerator. I made it look like it's up on the top. If I write it down here, lots of people I see write it down here make silly mistakes, I should say, and mess it up and go wrong. When I look at this one here, there are two ways to think about it. One way is what I call multiply the tops and multiply the bottoms. So I'm going to talk about that one first. So the top's 4 times 1 is 4. Now some of you watching will already realise this is too easy to you. 4 ones are 4, and the bottom only says 4. I could say there's a 1 there and talk about the 1, but it says 4, so that's 4 out of 4. This one over here, 3 times 4 is 12, depending how your brain operates, as to which method you go. So that's a 3 times 4, and I call it multiply the tops and multiply the bottoms, go over and over and over. The bottom only has a 4, so I've got that there. So I've simplified that ratio into that. How many times does 4 go into 4? And that's once. How many times does 4 go into 12? You go 4, 8, 12, and that's 3. Now go back to the original question when I wrote it like this. Any numerator, any top, can cancel with any denominator as long as you're multiplying. Now you can also do it straight up and down, but for today we're talking about multiplying. That is on the top, that's on the bottom. 4 into 4 goes once, 4 into 4 goes once, and I'm left with 1 times 1 divided by 1, which is 1. What's this one there? Numerator, denominator the same. 4 into 4 goes once, 4 into 4 goes once, and I'm left with 3 times 1, which is 3, divided by 1 is 3. And I find most people find that method the best in the long run. So if I go to number 2, there's 7th. Now some of you will look at it and you hardly need it, and you'll go that's 2 to 4, and then you'll simplify that fraction down. So if I multiply this side by 7, I multiply that side by 7. 7 into 7 goes once, so 7 into 7 goes once, so it's all ones. So have a look at what we've got. 1 times 2 is 2. If you wanted to be fussy, you could just multiply the top says 2 and the bottom says 1. This one, multiply. Now let's go cancel the 7s first. 7 into 7 goes once. My brain switched off for a second. 7 and 7 goes once. I got 4 ones are 4, and on the bottom I've got a 1. How many ones go into 2? It's twice. And how many ones go into 4? That's 4. So there's your simplified fraction of that to there, but they're still both even. Keep talking about 2, 3, 5 and 7. So they're still both even. So I can halve this side as 1, and I can halve that side as 2, or I can go 2 into 2 goes once and 2 into 4 goes twice. Now the video is going to become too long, so I'm having a look at this. If I multiplied that by 3, the 3 would cancel, but the 2 wouldn't cancel. If I multiplied it by 2, let's go back to here. If I multiplied it by 2, the 2 would cancel, but the 3 wouldn't cancel. So there's a very simple number that will make both of them cancel. And a lot of people will just go 2 3s are 6. So what we're looking at is the smallest number that 2 and 3 will both go into. And if you just go 2 3s are 6, a lot of time it works, but not all the time, which will be this one here. If I multiply that by 6, I multiply that by 6. Now, if you're a multiply the tops and multiply the bottoms person, you'll go 6 ones are 6 on 2. Then you'll go 1 6 is 6 on 3, so it depends how your brain operates. And you go 2 into 6 goes 3, 3 into 6 goes 2. If you're a cross out person, 2 into 2 goes once, and 2 into 6 goes 3, and you're left with 3 times 1 is 3. 3 into 3 goes once, 3 into 6 goes twice, and you're left with 1 times 2 is 2. And I didn't even mention the fact that they were 1. So without making this too long, but trying not to go too fast, if I said 4 6s are, and I could work out what 4 6s are, that's 24. I couldn't multiply that by 24 and multiply that by 24. Because I know 4 will go into 24, and I also know that 6 will go into 24, and you've got to figure out how many times. There is a better number than 24. I found over the years that the students who use 24 tend to get more mistakes than the students that would use 12. And a lot of students get stuck, especially if they're struggling on this, which more than likely the people watching it is those who are not confident on it, wouldn't fully understand why we go to 12. I can do this though. I call them the 4s. That's our 4 times tables. So if I write down my 4 times tables, 4 and 4 is 8, and another 4 is 12, another 4 is 16. And I can write down my 6s, my 6 times tables. So that's a 6, and another 6 is 12, and then you say, oh, look at that. 12 belongs on the 4 times tables, and 12 belongs on the 6 times tables. That means that 4 will fit nicely into 12. So how many times would 4 fit into 12? 1, 2, 3. So 4 into 12 goes 3. And then I can go multiply the tops and multiply the bottoms, and 3 3s are 9, and I don't bother writing the 1 on the bottom. So now I can go 6 into 6 is once, 6 into 12 goes twice, and then I can go 1, multiply the tops, 1 times 2 is 2, and the 1 on the bottom stays as 1. So I don't have to write 9 over 1 and 2 over 1. So that's 9 to 2. By the way, if you think about it, I got 3 quarters. So if I split a pie up into 4 pieces and I colour 3 of them, that's called 3 quarters. Or if I split another pie up, say it's the same size pie, and I split it up into 6 pieces, it's going to be rough, but there's a 6, the 6, the 6, the 6, and that's a bit rough. It'd be nice if I did it a bit more accurately. One of these is called the 6th, and you can see that the 1/6 is much, much smaller than the 3 quarters. So this is much bigger than that, so it's a ratio of 9 to 2. You can see how much bigger that fraction there is than that fraction there. Now, for some reason, these really muck people up. It's like they get used to that, they're going okay, and we put a whole number in, and the whole number mucks people's brains up. If you wanted to, you could write the 2 as 2 over 1. Now you can look at it and go, I want to get rid of quarters, so how can I get rid of quarters? If I times this side by 4, I times that side by 4. Now this already has a 1 on the bottom, so I don't have to do anything with that 1, because it's going to end up multiply the tops and multiply the bottoms as 8 over 1, and I don't have to write over 1. 4 into 4 goes once, and 4 into 4 goes once, and I'm left with this one, which is 1 times 1 is 1 over 1, which is just 1. So the inching part, we're saying that 2 is 8 times bigger than a quarter. Now I can go back to circle, so if you've had enough, you can switch it off and wait till we have more videos on it. So if I had, there's 2. If I had 2 pizzas and I wrote it in quarters, that would be 1, 2, 3, 4, 5, 6, 7, 8. That's 8 quarters if we wanted to do it that way and think it that way. Whereas this one is 1 quarter. So how big is 1 quarter compared to 2 pizzas, or I should say it the other way around, 2 pizzas compared to 1 quarter? It's 8 times bigger. So it's an 8 to 1. Last bit for those who need it. 1 1/3 is annoying. which you really need to turn it back into. And I can draw my circles again. I can go, there's 1, and then I could draw, let's draw a third about, say about there somewhere. So there's 1 and a third, so if I split that up into pieces, I've got 1/3, 1/3, 1/3, and 1/3. A whole lot of you know the shortcuts, but for the moment we've got 4/3. 1 whole and a third is 1, 2, 3, 4/3. So what are we doing? The shortcut most people teach is 3 times 1 is 3. There they are, the 3. Plus another 1 makes 4. So 3 1s are 3, plus the 1 makes 4. So we're basically saying how many thirds are there here? A lot of people, when I've been tutoring over the years, I can get them to say the 1 is 3/3. And you've got another 1/3, so that's 4/3. Now you can write the 3 as 3/1 if you want to. If that's the way your brain operates, you want to do that. Then I come to look at this and I can go, if I times that side by 3, I times that side by 3. And then you can go to multiply the tops and multiply the bottoms, or the way I prefer, I can just cross out those 3's. And when I cross them out, they don't become nothing. They actually become 1. But if I got a 1 times a 4 over a 1, how much effect does the 1 there have? Nothing. How much effect does the 1 there have? Nothing. So I can look at that and just go, that's 4. Now then I've got 3 times 3 is multiply the tops. So it's actually 9 over 1, but that's just 9. So the ratio is 4 to 9. Let's have a look for a moment. If you had 1 and a bit of a pizza, and someone else had 3 pizzas, who's got more pizza? They've got a lot more pizza than these people have. And if you write it as its simplest ratio, these people have got 9 lots compared to their 4 lots. So these people have a lot less pizza, these people have a lot more pizza. So you can always turn it into what we call improper fractions, and then go on multiply. I'm getting rid of thirds so I can multiply. And it can go on and on, make it complicated, but that's enough for today. If you're enjoying them, I hope it's helpful. Please just let me know if you're enjoying them and want me to make more, or let your friends know. And if you really want to, you can press subscribe.